Yeah. Shall we start? Okay. Guys,
We can start.
yeah, guys, hello. Welcome to this tutorial. Yeah, I go ahead with the same good old question.
Good evening, sir.
Yeah, hi. So, yeah, please tell me whatever queries you have regarding the topics that you might have looked into. Okay. Now, if you can tell me, we can look into those queries and then we can start our discussion from there.
Right, sir. Sir, so there were a few things that I am a little bit confused, stuck at, sir.
Okay.
Like, sir, one question I had actually also asked Nitin, sir, yesterday in the office hours. Sir has also shared a paper with me, which can help me to get the grasp of this one particular thing better. But, sir, I just wanted to put the question again in front of you as well. So,
Mhm.
sir, in the at the end of the first week, we were talking about the uh, what do you call it, sir? Like there was a function space, right? Space for I think it was gamma, the function space where we are supposed to find our optimal function. And sir, it was mentioned that like there were two things mentioned that I mean, sorry, there was one thing mentioned that there's a chance that we might, while solving, we might not find the optimal function t star x in the gamma function space. So sir, my first question is, like, why is that the case? Like, we are looking for the solution in this space, so why is there a chance that we might not find it in the first place? Then why are we looking for it here in the first place? That is my one question, sir. And second question would be that the function space gamma, I mean, as of now, sir, we just know that we are looking for the solution in this function space. So sir, like, down the line, or like, I'm not sure if I missed it, but down the line, would this function space be defined in a more strict manner, so that they, like, there are some conditions which are to be satisfied in order to become a element of this function space? Is there something like that?
Okay. So, uh, first, let's go to the first question that you asked. Now,
Right.
it is possible that not every time the optimal value, or see, you have a function and then you have certain restriction. Not every time all the restrictions will be satisfied. Okay. Now, one example that I can
Okay,
give
sir.
you is, now there are four friends. Okay. So now one person is working from 4 a.m. to 10 a.m. The other is working from 8 to 12. The other is working from 10 to, so you're seeing that, right? You are able to see that. Now, is there a way in which all four of them can go to a movie?
Um,
Is
for
it?
No, sir, because like
There is no
I
way. There is
yeah,
not a time in which all
right,
four of them are free.
right.
Now, similar to that, okay, this is what you are looking into, right? Is this the function that you are speaking of?
Yes, sir. Yeah, this one, sir. Yeah, yeah.
Okay, yeah. So now here, the space of function t that we are optimizing may not contain the optimal t star. Now, when is this possible? Now, it is possible now when the constraints that we have put in may not be fully satisfied. Okay, at that case, you will not be able to find it. Okay. Now, does that intuitively answer your question? Now, what are the constraints that we are putting? Just go back a bit back. You will be able to
Right,
know
sir.
what are the constraints that you are putting. Is that
Right.
clear? The first point is
Uh, Makes sense. Yes, sir.
okay. What
Yes,
is
sir.
the second point that you rose?
Sir, like, the second question that I wanted to ask, like, so by the way, is this function space, is it just T or is it gamma, sir? Like capital gamma? I'm not sure
Oh,
what to
this
call it.
is T actually. I got your confusion.
Yes, sir.
Okay. Now this is the see when we just write T, you might get it confused. So what we
Right,
have
sir.
done is we have just put a script here.
Okay, sir.
This is the
Script
T.
T. Okay, sir. So, sir, like the second question is a bit, I'm not sure if it is generic, but sir,
Hmm.
like this function space scripty, like like down the line, would we see it again with like more specific definitions, like like the constraints or the conditions that are to be satisfied in order to
Yes, yes,
be.
yes. Now, once you go further, that will be clear. I think you haven't looked at the VDM formulation and how you realize GAN using that. Correct?
Sir, I have just started the second week, sir. So I have not gone into depth as of.
Yes, yes, yes. So it will be clear at that time. Don't worry.
Okay, okay. And sir, sorry, another thing, sir, that I wanted to ask you about, sir, I mean, when like while starting the second week, sir, in that particular topic, realization of VDM, sir, there when we are replacing the lower bound of the divergence with this equation that we got at last week, sir, like the one we were talking about. Sir,
Yes.
there I saw that the Supremum is being replaced by Max, sir.
Okay.
Uh,
See, so
yes, sir.
until unless you are very much clear with the idea of the difference between supreme and maximum, for all practical purposes, it is same for us. Okay. So
Okay,
now,
okay,
if you remember that now somewhere, Sir also makes that thing. See, he says that if you see that the one that I'm currently pointing, it is coming. Just wait. Yeah, he writes supreme and then in bracket he write
bracket
max.
Max. Right, right,
Okay. Now for all practical purposes, we can take supreme and maximum. Now, if you want to know what is the difference between maximum and supremum, now there are Wikipedia pages that are available that will help you
right,
out the difference between the supremum and maximum.
right, sir.
Now, for all
Right, sir.
practical purposes, it is same for us.
Okay, sir. Okay. Okay. And sir, like one last small question because
Go ahead, no
I
problem.
didn't get the chance to dwell further. Sir, so I was just going through, I was skimming through the like implementation of VDM, sir, and sir, then I came across the discriminator. So, sir, like I am a little bit.
You haven't started with GAN, right?
Uh, no, sir, I have not started with GAN, yes, sir.
No, this is
So,
the discriminator
yes,
network. Yes.
right, sir. So, sir, like I was just going through in the VDM parts are only. I was just going through the discriminator. Sir, could you just like since I have not started GAN, so sir, like could you just give me a small idea regarding what the discriminator does? Sir?
Okay. See, the idea of discriminator is to classify. Okay. Now, classifier
Okay.
is called as the discriminator. Okay. So now I presume that you know the idea of classification, right? Now, you have some
Yes, sir.
input. Hmm. You want to put it into some discrete big buckets.
Right, sir.
Okay. Now, that is
Right.
what is called as the idea of classification. Now, in this specific realization of VDM that we look at GAN, now our discriminator will be a binary classifier.
Okay. Okay.
Okay. Now it will be a
Okay.
binary classifier which will be discriminating between the real images and the generated images.
Right.
Okay.
Okay. Okay, sir.
As you go further, now things will get clear. Don't worry. Okay.
Okay.
Now you got the
Okay.
idea why it is called as discriminator,
Yes, sir. Because it is basically classifying, discriminating between which is what, sir.
and
Right.
it is also called as a critique network. Now, in the things that you see outside, you see a lot of blogs and places. No, there they either say it as a critique network or a discriminator network.
Right.
Both of them, for all our purposes, it will be the same.
Right.
Okay.
Sir, just out of curiosity, you mentioned critique network, sir. Sir, does it have anything to do with the actor critique model from reinforcement learning? Okay. Okay.
Not that I am aware of. No, the reason why it is called as a critique network is now it is saying that it is able to say that okay, it is in a what do you call what does a critique do? Now the
It
critique will say that
Yes, sir.
whether it is good or bad, right?
Good or bad? Yes, sir. Right. Okay.
It is act the critique will also actually discriminate, no, what
Right.
is real and what is no what do you call not so great. Okay? That
Right.
is what even this particular thing is.
Right. So, sir, the like the argument for the critique discriminator, sir, it is it the like the output of the generator network.
See, it takes both the real images as well as the generated images.
Okay. Okay. That is
Okay,
okay.
now just go forward. Okay, and finish off the realization of and the coding of the GAN. Now, all these questions will be cleared off. Now, in GAN implementation, we have specifically dealt on this. Now, what is the input?
Okay.
So the different kinds of input. How do you actually translate your loss function into a neural network, and how do you solve it?
Right. Right.
We
Okay,
have
sir.
specifically dealt there. You can
Okay.
look at it. Okay.
Okay, sir. Definitely. Definitely. Thank you, sir.
Yeah, ask me any questions, no problem. So if there is some other place, I will say that it is here. Now, if it
Right.
is not there anywhere, no, we will be able to rectify it here and here.
Okay, sir. Okay, sir. Sir, like one last question won't take
So
much
go
time.
ahead. Even if you have 10%, I don't have any problem.
Sir, like this is a, not a technical question, but an approach related question. So, sir, I am a little bit like, sir, my coding skills are not that good, and now I want to go ahead with your PyTorch sessions, sir, but I am a little bit reluctant. So, like, sir, like, could you just suggest an approach to go for
See,
these?
always I say this. So now consider that I come to your home
Right, sir.
and then I'll ask you, okay, Satyaki, now you tell me, how do I get a pen? No, you will say that, okay, now either you will go and get me the pen, that is one approach, or you will say that, no, Chandan, you go straight, no, you find this, you take a left, you give me a precise instructions to do the task, right?
Right, sir.
Okay, that's what we generally do. Okay,
Right, sir.
so now similarly here also, uh, there's a call and then now here also in a similar manner we will do. Okay.
Okay, sir.
Now we
Okay.
will give precise instructions. Now do this, do this, do this, do this after this, do this after this. There is a precise set of instructions that needs to be taken.
Right, sir.
Does this make sense?
Yeah, yeah. Understood, sir.
Ah.
Yes. Thank you, sir.
Now, whenever you are looking at coding, now that is how you should look at it. You should say, look at the precise set of instructions. Now, what is that instruction doing? How do you give that instruction? And what instruction should be given after what? Okay.
Right, sir. Understood. Thank
Yes, Gautam, go ahead.
Yeah, just a question on the uh, what are the applications of the saddle point problems other than this GAN network? Is there any other application where it is used?
Okay. I'll give a different answer to that. Have you looked a movie called as The Beautiful Mind?
Yeah, I watched it long time back. Yeah.
Okay. Do you know the name of the hero, right? He is Nash.
Yes, Nash equilibrium.
Yes. Now, can you relate the saddle point problem and Nash equilibrium?
Yeah, it's no, I cannot because I don't remember the
Yeah,
movie at the
you would have watched
moment.
it long. So here is the hint. Now, it is used in a lot of places, especially in game theory. Okay. So now, uh, just go and read it about Nash equilibrium and the saddle point problem. Now, most of the things that we see here is a saddle point problem. Okay.
Okay.
Now, for example, you are in a hurry, you are going on a traffic, someone is also in a hurry. Now, both of you collide. Now, how do you resolve this?
So we have to choose a different path, I think.
Someone has to, someone has to adjust, right?
Yes.
That is the saddle point. Just look at the Nash equilibrium. Things will be clear.
So from the point of decomposing the generator network into, sorry, the discriminator network into two functions, uh, what is the necessity of it? Because
Where did you decompose
already
the operator into two functions?
uh, here the f star tw of x is split into two functions, right? as two components. One is the sigmoid function, and other is the
See, okay, okay.
yeah.
Why do you need a sigmoid function? Okay, now that is your question, right?
The first part is why it is split into two parts, because we are assuming that any neural network can be the neural network can represent any function as a universal approximating function. So why do we need split into two functions? That is the first part of the question.
Okay.
And the second part is I was lost in getting the sigmoid in the derivation. So how did sigmoid come up? That is
So
the
now, do you remember that there is something called as F divergence specific activation?
yes. Why do we need it?
Okay. Uh, yeah,
Yes, that's this part. Yeah.
yeah.
So why can't the neural network represent can map from X to domain of F star directly? Why do we need to split it into two parts?
See, okay. Now, for all practical purposes, both are same. No, this is function one, function two, function three. Whether you go to here and here, or you directly go here, no, it's for
Yes.
practical purposes. It's the same. No, we
Yes.
needed to use this. Okay, now this is the need for the F divergence under consideration, which is Jensen-Shannon divergence. This was needed. Now to map, okay, I don't recall the exact values. Now you want to map from 0 to 1, right?
Output is R minus.
Yes, yes. So yeah, because of that, you wanted to use this activation. Now this is the activation function which is specific for the F divergence under consideration. Okay.
Mhm.
Now if you want to use some other F divergence, okay, well and good. Now you will use some other activation. Okay.
So now this is applicable only for GAN. So if we
So
choose a
this is for
different,
any medium.
okay, any
Now,
video.
GAN is one specific approach of medium.
Mhm.
Now you are still in medium. Now till here you are in medium. Now then you look at a specific application of medium, now which is the generator. Which is the generative adversarial network GANs.
Okay.
This is one specific implementation.
Mhm. So in the GAN, further it is given that the domain of F star is R minus.
Yes,
Uh,
in this specific.
so
Why?
yeah, in this case,
Because the F that you have considered is this. The choice of F
mhm,
divergence is this.
yes.
Now, because of which we know that if this is the Jensen-Shannon divergence, okay. Now, what should be the F star? We know. Now, then we have to use the activation function, which is specific to that. What do you call uh, divergence and the consideration?
So is there any relation between the domain of F star and the range of F? Are they the same?
Domain of F star and
Range of F. F is u log u minus u plus 1 log u plus 1. So is there any relation or are they independent or something? Because there's a conjugate function, right? So
they have to be related for sure. I don't know what exactly is the relation. I'm not aware of it.
mhm. Okay. So I'm thinking conjugate in terms of inverse. So that's not a
I
inverse
got
thing.
your point. Okay.
Mhm.
Yeah, not that I'm aware of. Maybe I'll look into it and then maybe in the next live session I'll be able to put some light on
Okay. And in the implementation of the GANs, uh, it was given that we have to, I want just to confirm, we are doing 3 forward passes and 1 backward pass during the training of discriminating network.
No, you'll do 3 forward pass and 3 backward pass. 1 forward pass, 1 backward pass. Now you will train the generator thrice and discriminator once. Now that is what gives us good result in MNIST case. That might be different, something different from some other particular
So can you repeat again? Three forward pass and
three see three updations,
okay.
of generator and one updation of discriminator.
Mhm.
So whenever I say updation, no, that means that there has to forward pass and then has to happen a backward pass. Both of them has to happen. Okay.
Okay. Yeah. So my definition of forward pass is that
Forward passes, you get the outputs and
yeah.
then you compute the loss and then get the gradients. Now that is the backward pass and updation of weights. Input.
Yes. Yeah. So the now for the discriminator network training during the forward pass, we are passing twice through the discriminating network and one through the
Yes, yes,
generating network.
yes.
Yes.
At that time, you will make one. So the generator as this, right? You will not. It will be the evaluation.
Constant. Yeah.
Now you
Okay.
might have. Let me go to the diagram. Now while training the discriminator, okay. Now you only go till here.
Yes.
You want to generate this. I got it. So you want to generate these things. At that time, you will put this in evaluation mode. But updation is only till here. You will not go further.
Yes.
While training the generator network, you have to go till here. Okay. But what do? You keep this W as constant. Now that means that you will keep them in evaluation mode and then you update only. Now the one more way in which we normally evaluate it is we have a different optimizer for this, different optimizer for this. When you have two different optimizer, when you say that update weight with respect to optimizer one, only the weights that are associated with that optimizer will be get updated.
Okay.
That is what we will do.
Yeah, I think that's all I have. Yeah.
Yeah. Uh, Guys, any questions you have? Any specific questions on whatever we have looked into till now? Any suggestions you have? Any modifications that you want us to do, or you have any clarification with respect to the way in which things are happening?
Yeah, just another question.
Hmm.
In the final part of this hour's lecture, he told about the batch gradient descent that sometimes even the generator network is done multiple updates for one update of the discriminator network. Is there any application?
See, the idea is you don't want to make your discriminator too strong. See, if your discriminator become too strong, if you update it too many times, now what will happen is it will be able to differentiate. Now you don't want it to differentiate, right?
Yeah.
Now, because of which you have to train it much lesser. Okay, that is the reason why we train generator more number of times and discriminator less number of times.
So, but other way around, is there any application or any data set that is applicable?
No,
No. Okay.
see, because it defeats the purpose, right? If you train
Yeah.
too
Yes.
much, actually it will be able to say about the domain very easily. Okay, whether it is from the real data or from the generated data. Now you don't want it to do it. No, that means that the training has to uh, make sure that it is not able to do it, right?
Okay. Sure.
Now to make these live sessions interactive, much more. Do you want anything? You can give us some suggestions so that the course can happen much more comfortably. Now, what I have made myself is I want to keep it as a very much doubt clearance session. Now, if you want to need something else, now, if you can let us know, we will be surely, if it is possible to accommodate, we will surely accommodate.
The last week, the discussion we were discussing about the conjugate function. How did that conjugate function come up in the week one and you suggested some YouTube NPTEL lectures. I
Hmm.
went through uh, the convex nonlinear optimization playlist, but I didn't find anything related to this conjugate form. So, can you refer to me any other playlist or document to get that
Oh, that is.
understanding?
Let me look into it. Right. Just a minute. Okay. I found a couple of videos, independent videos. I just share them with you. This is also from NPTEL. This is on conjugates, conjugate function of. And then there is one more video from CM View. This might help you out, is what I feel.
Okay, I'll go through them.
Sir, this problem of mode collapse in GANs, is it related to training data set?
No, that is not related to training data set at all. Even if you have a very good data set, also the mode collapse will happen. Now, why do you think mode collapse? What? Okay, let me ask you this: what did you understand by mode collapse?
Uh, since since we are switching both the classifier and the generator, both we are tweaking the parameters of both of them. So if we move to if the model is able to discriminate properly between two clusters, then we create a third cluster by tweaking the generator. So if the main will move to over there, and it will perfectly discriminate between two and three, but it will fail to discriminate between one and three. So this keeps rotating among the clusters. So
The image that I'm
I
showing
thought,
you.
yes, sir. So I thought maybe the training data set might be.
It is irrespective of the set that you have. It is because of the way in which the problem is defined. Okay. So week 5 is not yet out now, which is VAEs. Now these problems will be very nicely resolved. Just wait out for it.
Sir, so this T of x, the function T of x that we create in the discriminator. So is it a set of affine functions? Like since Sir explained that the curve will be approximated to multiple subgradients. I thought maybe,
Which TX are you referring to? You're referring to the formulation, or in Versenstein GAN we use the TX?
yeah, the supremum T of x, he introduces
Okay.
TX.
Are you referring to this T of X, or let me go to the source itself? Are you referring to this T or this T? Which T? Script T or just plain T? This or this? First one or second one?
I think I'm referring to the strip T, sir. So I think that is the
Oh,
affine.
oh. This is the bag of all functions. Okay, tell me. What of
In the function, so the bag is made of all affine functions, linear functions. So
Now, why do you feel that it has to be only affine or linear?
Uh, in servers drawing multiple straight lines in one of the directions. So
Now, that was just to give you an example. That doesn't mean to say that you will have only affine functions. No. He wanted to just make sure that what do you mean by a lower bound. Now, you are referring to this thing, right? The way in which he wrote a parabola, and then he wanted to write a lot of lines here, and then say that which is the tightest linear bound. Is this what you're
yeah,
saying?
yes, sir. So for each x, we are trying to find a one
No, that was
function.
just an example. No, we don't have any restriction saying that no, it has to be only an affine form. Yeah. Go ahead. Any other questions you have? So you're going through my notes. Nothing as of now. Okay, good. So now, if you want any additional things like, okay, no, we can do some other thing. Apart from, please don't tell me that go through the whole thing that has been covered in that week. Apart from that, if you want any other activities or any other kinds of, uh, apart from doubt clearance, now if you have anything in mind, now you can let us know. Or if you have got any specific feedback on how things are happening, and then that is also fine. You can give us any update on that. Now, how are things till now? All good? No problem? You're enjoying the mathematics of generative AI?
Yes, sir.
Yes, sir.
Have you
Yes, sir.
ever thought that so much of mathematics will be involved behind the clicking buttons? It was even shock to us also. But anyhow,
So, like you mentioned in the last live session, that usually I'm not trying to generalize, but maybe a lot of people came to it with a framework sort of mentality, like they are probably. But I think this one is better probably because we are getting to learn how the thing works. So yeah, that is much better
mine's so bad.
and much interesting.
Yeah.
So, yeah.
Now, once you get the grasp of that language, the way in which you want to present your idea with respect to an equation, you'll be more precise and it will be very much comfortable.
Right, sir.
Yeah,
Right, right, right.
that is the first thing that you want to appreciate. Okay, so any other questions you have?
Not from my side, sir.
Okay. Anybody else
Yeah,
has any? Yeah.
is it possible to have some practice assignment questions as well?
Okay. In sense, okay. What do you want? Practice assignment in the sense?
Yeah, there are graded assignments, that is
Yes.
the quizzes
Quizzes.
every
Okay.
week.
Yeah.
But this can be, we can get to know the answers only after they're completed, right?
Yes.
So, but if there are practice assignments, we can do similar type of questions, which we'll
Okay.
get
Some
the
kind
results.
of mock quiz kind of a thing. Mock
Yeah,
question
yeah,
bank kind of a thing.
yeah.
So let me see whether we are able to generate it, whether we are able to get the questions or not. So since this is a non-standard course, So you don't have any textbook from which I'll say that, okay, now you go ahead and refer to this textbook. Now that is because this is compilation of papers. Yeah, we have to see now what is the best way to do this. Just give me some time. That's actually a good suggestion. I'll speak with professor once, and then if it is possible, we will surely do it.
Yeah. And last week we were also referring to some papers for the GAN. So is there any one paper, or we have to refer
No,
to
no, there
two?
are multiple papers. See what has. Okay, just wait for 2 more days. By Monday, you will get a list of papers, okay,
Okay.
which you can start looking into.
Okay.
Any other questions you have? No questions. All of you have access to Sir's handwritten notes, right?
Oh, yes, sir.
Yeah,
Yes, sir.
you have it preemptively before you look into the thing, and then that will be really helpful.
So the week two GAN Python collab it's not been sad.
What?
The week two Python notebook.
Week 2 Python. No,
Yes,
week 2,
notebook.
I think we did PyTorch, right?
Yes, sir. So the GAN implementation.
Oh, GAN implementation, okay.
That notebook has not been sad in the portal.
Okay, so what I'll do is I'll share you a Google Sheet, so when which you have access to all the collab notebooks and then all the papers. Okay. Now collab notebooks are actually ready, but there is a delay with the papers. Okay. So by Monday you will surely get it. You're able to run it. You're able to run it for multiple epochs and generate at least some decent images. Any other questions, guys? You have? Yeah, so you have to implement it. Okay. So what at least in the first week of implementation it will be very simple. Now from the second that is from the third week, now once we complete DC GAN, there is something called as deep convolution GANs. After that you will have a lot of changes to do here and there. That will be fun. Now please don't, I urge you, please don't buy any GPU. Okay. Now the so we have designed our experiments in such a way that the whatever collab provides us would be more than enough. So that is the reason why we are taking a very simple data set which is MNES, and then now we are make sure that we use smaller networks and then show you the results. Okay. Now our aim is to give you a hands-on with the resources that is available for us for free. Okay. Now please don't buy any GPU from anywhere. We don't need such. Okay. Some exercises to test our understanding. Okay. Uh, yeah, we haven't. So now one thing is how do you map? How are you able to understand whenever you see an equation? Are you able to map it to its implementation directly? Now, if you are able to do it, now that is a straightforward way in which you can say that you have understood or not. Okay, now that is the first thing. You see an equation, are you able to map it to the implementation directly? That is one litmus test that you can think of in terms of understanding. Okay, that will be really helpful. That is how, as a computer science person, I look at it. Okay.
Sir, there was this one thing. Since it's not sir related to anything technical, but sir, like in the last term, I had this subject called reinforcement learning, and in that, sir, there were certain sessions where students who had taken reinforcement learning, they had to present. Like they had to present a paper, not exactly a paper, sir, like not their paper, like they had to read a paper and
Read a paper,
Yes,
kind
sir.
of. Yeah, got it.
Yes, sir. So, like, they had rolled out a form for interested students, and the students got to select There was a list of papers. The students got to look at the list, select a paper, and dates were allotted to each group, and they
Hmm.
presented. So, sir, it was pretty interactive, and like it sort of added to the thing, lectures and everything. So, like,
Sure.
in case it is possible down the
Yes,
line, ever.
it would be possible. So the thing is, now since we have already rolled out the scheme of evaluation, I don't know whether it can be added as an evaluating component. But
Right,
if it is a non-evaluating component, definitely we can do it. If
right,
people are if people are willing to present a paper and then say that okay, now you say that okay, Chandan, I'll present this paper next week. Now I'll be first I will go through that paper, and then so it will be really helpful. Okay, for you also,
right.
it will be helpful. That will be really nice. Now I'll speak with Professor Vans on this. Now there are a lot of things that I should ask sir this week. Yeah. Now one is
Okay.
regarding your some kind of a pre-mock questions. Sorry, mock questions itself is before exam. I don't know why did I use. And then regarding the papers, okay, both of them I'll get back to you, and then I'll see to it that information reaches you beforehand.
Thank you, sir.
Okay, good. So yeah, we had an interesting discussion. So keep the questions coming. Go to the videos. Any queries you have, note it, and then we can discuss it in the live sessions. Yeah, all these assignments that you have given to me, I'll see to it that that is taken care of. Okay, that's all from my end. Then. Yes, Nitin. So we can